Okay, just wanted to take some time and talk a little bit more about the sand and defects in castings that might help us out. I talked about in one of the videos a squeeze jolt machine. Here we have a cope and a drag on a machine. You would put boards that would transfer the energy from this, and basically it's a cylinder that you could push these two levers right here, and it would come down and squeeze the sand for you. So you're going to be the squeeze jolt machine in this lab. Now the sand is basically has three properties that we like to have, and I mentioned some of this in the videos. We have cohesiveness, which we want to be able to hold that sand and compact it and hold shape, and that's going to be important. The permeability, we don't want to pack the sand so tightly that it's not porous. We want it to be cohesive but still have some porosity aspect, and that's going to let the air come out of the molds. We can take little wires and punch vent holes in there if we want to help escape those gases, maybe alleviating some of our porosity problems. Collapsibility, we talked about a core at one time that basically as the metal cools, we want that core to crush so that the material doesn't develop a hot tear and rip apart as it's shrinking. In lab, we're just going to be mulling our sand by hand, and I'll probably bring a mixer from home. We have what we call a muller typically that we would add water and remold the sand and recondition it. So you're going to have some kind of what system for reconditioning the sand. Now, when we look at the sand has certain measurements that we can do. We can come in and measure the permeability of the sand and verify that the batch is good. We can compress the sand and see the strength of that sand. Again, that sand has sand, clay, which is bentonite, and water mixture in there. We don't want to add too much water, just enough water. And so we can do a hardness test of the compressed sand as well. Now in lab, we're going to be using a green sand that's water-based. I like to use an oil-based, but that puts off a smoke and you have to be in a well-ventilated area. And those are the two major sands that we normally talk about. If it was a major class, I'd be going into a lot more detail about these kind of things and the different kinds of sands. But some of the defects that we might see, you guys are just doing a single sided pattern that you're going to make, just free patterning. So your cope is going to have the cavity and not the drag. And so what you're going to see is you're probably not going to get shift, but we could get shift where those two are not lined up. So we need alignment pins and stuff. If for some reason the cope and the drag don't sit together very good, you're going to get flashing at that parting line, and that's could be an issue. Misrun, that's where we don't actually get enough metal going into the casting and it doesn't get all the way around and doesn't fill. So some of you might have a misrun that your cavity fills up partially, freezes off, and doesn't fill the rest of the way. We could have shrinkage, and this is some shrinkage looks here. These are the top of the part where we have the shrinkage cavity. That's probably from an inefficient sizing of the riser. And what's going to happen, we're going to see these shrinkage marks in there. So you might want to look for shrinkage marks on your castings. Here's a cold shunt or a hot tear where basically the metal went around and did not adhere. And sometimes that's shown as a line, which we won't have in our casting. Another thing is if the sand has variable properties, it may let the metal to penetrate. Again, that could be the difference in the fluidity of the metals and having little skin blemishes on the casting as well. Now we talked about draft, and this is an example of draft where if we have straight walled size, it's going to be hard to pull that part out. Our blocks that we have draft in them, so we can remove the pattern fairly easy and not destroying the sand mold. So we need to have some kind of draft angle to do that. And that needs to be on all vertical surfaces. During solidification, if you had a really thick section versus thinner section, this thicker section may cool slower, feeding the rest of the sections, leaving a void. So a lot of times when we do a casting, we cut it open, look inside, and we may want to do that with some of our castings is cut it up and take it over the saw and look inside and see if we can see anything. Some of the things we can do is put metal chills next to the area and enhance the cooling rate in this area.